do a little bit of work with the Pythagorean Theorem, which I'm sure many of you have already heard about. So the first thing I want us to do is to write down what the actual theorem is. So a theorem is something that it's like a statement in math that's already been proven to be true. Now that it's been proven, it's something that we can use. So the Pythagorean Theorem states in a right triangle, and this only works in a right triangle. So in a right triangle, the sum of the squares of the legs, remember the legs are the two shorter sides, so the sum of the squares of the legs is equal to the square of the hypotenuse. Remember, the hypotenuse is the longest side. So in a diagram such as this, with my right angle marked, remember that my two legs are A and B, my hypotenuse is C, so A squared plus B squared equals C squared. The sum of the squares of the legs is equal to the square of the hypotenuse. A squared plus B squared equals C squared. So this is what you're going to remember, that A squared plus B squared equals C squared. That's the thing that we're going to use most often. And this is going to be used for a lot of different things. Pythagorean theorem is going to show up a lot in all of the math classes that you're going to take throughout high school. It's just going to keep showing up. It's going to be one of those things that you just remember as an adult. So it's because it's used for a lot of different things. I'm going to show you two of the most used applications. So first up, we can use this to determine if three given side lengths can form a right triangle. So let's look at example 1. If you are given the side lengths 3, 4, and 5, I can use the Pythagorean theorem to determine if I can plug these in and see if they would actually make a right triangle. Are these side lengths long enough to fit something like this? So we know that our longest side has to be C, our hypotenuse, so the biggest number is always C, and then the other two are A and B. I usually make A the smallest number and B the middle number. I'm going to tell you that for A and B it doesn't matter. And then we're just going to go ahead and plug them in. So 3 squared plus 4 squared equals 5 squared, and we're going to check and see if this is true. So I know 3 squared is 9, 4 squared is 16, and 5 squared is 25. 9 plus 16 is in fact 25, so that works. So right triangle with side lengths 3, 4, and 5 will make a right triangle. Yes, these can form a right triangle. Let's look at another example. So for this one, I have side lengths 8, 9, and 10. So the longest side, the biggest number is C. I'll just label these A and B in order. So we have 8 squared plus 9 squared equals 10 squared. 8 squared is 64. 9 squared is 81. 10 squared is 100. These add up to 145. 145 does not equal 100, so no, these side lengths do not create a right triangle. The other thing that we can do is if we are given a diagram with a right triangle, we can solve for a missing side. So our first example for that, given this diagram, my right angle marked here, I've got this top is going to be x, this side is 24, and then my hypotenuse is 25. So longest side, biggest number is going to be C. And then you can label the others A and B. Like I said before, it doesn't matter how you label them. I'm going to label the smallest side A and the middle side B. So A squared plus B squared equals C squared. A is x, so x squared plus B squared equals C squared. Oh, sorry guys. So I know that 24 squared is 576. So that left side is x squared plus 576 equals 25 squared, which is 625. Now if I subtract 576 from 625, I get that x squared is equal to 49. Ooh, look at me go. And I know that 49 is 7 squared. So that means x is equal to 7. If you get to your calculator, you get to this point and you're not sure what to do, you can actually take the square root of a number. It's right here over the squared button. So if you hit the second key and then you hit this x squared button here, it'll pull up this square root, and then you're just going to type the number on the inside and it'll pop the answer out for you. So for this one, the missing side length is 7. Let's look at another example here. Okay, in this right triangle, there is my right angle. Got this side is 16, this side is 30, and we will label this x. If you're having trouble determining which side is the hypotenuse, it is always going to be across from the 90-degree angle. So that makes my hypotenuse x. So x is C. And then again, it doesn't matter which order you do it. This time, I'm going to make 30A and 16B because that's the order that I read them left to right. Really doesn't matter. So when we plug those in, 30 squared plus 16 squared equals C squared, which is x squared. And honestly, if you leave that as C squared, it's not going to be the end of the world. You'll still get the right answer. So 30 squared, 900. 16 squared is 256. 900 plus 256 gives me 1,156. So that is equal to x squared. Now, as I had just shown you, I'm going to take my calculator, I'm going to hit the second button, then I'm going to hit the x squared key to get my square root symbol, then I'm going to put 1156 inside of that, hit enter, and the answer is 34. So x is 34, meaning that my hypotenuse is 34. We can also use the Pythagorean Theorem to apply it to real-world problems, which is what we're going to focus on tomorrow. But for today, we are going to focus on determining if 3 side lengths form a right triangle and solving for missing side lengths.